welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at addition and subtraction of polynomials. That is, adding and subtracting polynomials. By the end of this lesson, you should be able to understand what like terms are and why they are important. You should be able to add polynomials by collecting and combining like terms. You should be able to subtract polynomials by distributing the negative sign first, and then we should be able to simplify polynomial expressions involving multiple operations. As the lesson proceeds, here are some basic vocabularies you would be hearing, and I would want you to pause and then quickly glance through. The first one is a polynomial. The next is like terms. When you say coefficient, what is it? And then the degree of a polynomial, what is it as well? Without much I say, let's quickly look into it. So let's start this lesson by first of all looking at what like terms are. When we talk of like terms, we are talking of terms that have the same variable. So first of all, they should have the same variable. And as much as they have the same variable, they should have the same exponent as well. We are talking of variables and exponents. If these are the same, then yes, we can say we have like terms. So for instance, if we have the 3x squared, over here you realize that your variable is what? X. And then that of negative 5x squared, the variable here is also x. They both have the same variable, but out of the exponent, this is 2 and this on the other hand is 2. Since the variables are the same and the exponent are also the same, then we can say they are like terms. They are like terms. On the other hand, if we take, let's say, a 3x to the power 2 and then a 4x to the power 3, these two have the same variables. They are all having x. But over here, the x is to the squared, right? And then this is x cubed. So though they have the same variable, they don't have the same exponent, and hence they are not like terms. They are not what? Like terms. Knowing what is and what is not like term is very important because it is the foundation for adding and subtracting polynomials. So let's look at the rules for adding, which is the same as the rules for subtracting polynomials. First of all, you identify all the like terms in your expression. If you're able to identify all the like terms, you now add or subtract the coefficient. So we don't actually add and subtract the powers or the variables, but rather we do so to the coefficient. Take note, we do so to the coefficient. Then we keep the variable part exactly the same as it is. And we then present our answer in the simplified polynomial in the standard form. Now, there is something you need to take note of, especially when you are subtracting. So the warning we have here is regard to subtraction. It says, when you are subtracting polynomials, you must distribute the negative sign to every term in the second polynomial. With what we have here, we have 3x squared plus 2x minus 1 minus, into bracket, x squared minus 4x plus 3. This negative sign must be distributed to x squared. It should be distributed to negative 4x and then also distributed to what? The 3. So that if we are to maintain what we have right here, which is our 3x squared plus 2x minus 1, this negative being distributed to this x squared becomes a negative x squared, as you can see over here. You see the negative x squared. Then this negative affects this negative positive 4x to become, it affects this negative 4x to become a positive 4x. In the same way, the negative affects the positive 3 to become a negative 3, after which you do your subtraction. So with that said, let's solve some examples to enhance our understanding as well. So our first question we have here says we have to add 4x cubed minus 2x plus 5 to x cubed plus 3x squared minus x minus 2. I'm going to use two methods to do it. Then you can take any that you think you'd like best. So our question says 4x to the third minus 2x plus 5. That is in one bracket. Then plus the other being an x cubed plus 3x squared minus x minus 2. So the first thing you need to do is to open your bracket. As you can see, we have just 1 as the coefficient here. So the bracket is opened just as it is. Then plus the same way we have just 1 here. So 1 multiplies everything to give us the same thing. We have x cubed plus 3x squared minus x minus 2. After this stage, we then group like terms. We have said that group like terms are simply those with the same variables and exponents. They all have the same variable, so we just have to target the exponents. This has an exponent of 3. This also has an exponent of 3. So we can group them together. X, 4x cubed. Then this here is our plus x cubed. So this has been written. This has also been written. The next we can group is those with squares. This is the only one with a square. So let's just write that down. That is a positive 3x squared. So this is also gone. Then we now come to those with the degree of 1. That is, we have a negative 2x and then a negative x. So negative 2x minus x. So this is also gone. And then this is also gone. And then we now have the constant to deal with. So the constant, we have a positive 5 and then a negative 2. At this stage, you now simplify by looking at the coefficients. So we have, since this and then this are like terms, we just work on the coefficient. So we say 4 plus 1. 4 plus 1 simply gives us a 5. We have a 5x cubed, then 3 minus, okay, well, for the x squared, it has no other term to simplify with. So we just write plus 3x squared. Then we come to the x's. So we have negative 2 and negative 1. Negative 2 minus 1 gives us a negative 3 with our x written there. Then 5 minus 2 gives us a positive 3. This becomes our solution. Very simple, right? Okay, so this is if you actually want to take your time and group like terms. But there's another simple one which I'll illustrate in a moment. So for the other one, we have 4x cubed, then minus 2x plus 5 DC. And we want to add it to x cubed plus 3x squared minus x minus 2. So we want to use the column method. If you want to use the column method, then you would have to get each and every coefficient for every term. By every term, I simply mean for the 4x cubed minus 2x plus 5, we'll have to rewrite it as 4x cubed. You see, the first term is a cube, so the next should be a squared. But since there is no squared here, then we can rewrite it as plus 0x squared. Then now come to the x term, so minus 2x and then plus 5. So all we need to do is to rewrite this one so that it looks as you see over here. For the second one, it already has the cube, the squared, 1, and then the constant term. So that simply means using the vertical or the column method, this is how our addition is going to be written as. We have 4x cubed plus your 0x squared minus 2x plus 5. Then you arrange the next one in terms of what? The coefficients. So the next one in terms of the variables. So we have 1x cubed. So 1x cubed. Then the next one is plus 3x squared. So plus 3x squared. Then minus x. So minus x. And then minus 2. Minus 2. You see? And we are adding it. So the only thing you do is to bring your addition here and put this in your bracket. And then you put your equal to sign nicely. So you have 5 plus negative 2. 5 plus negative 2 gives us a 3. Then we have negative 2 plus negative 1. That also gives us a negative 3. So negative 3x. Mind you, this is plus 3. Then we have 0x squared plus positive 3x. That also gives us a positive 3x squared. Then for the last one, we have 4 plus 1, and they are all cubes. So we have 5x cubed. This is what we have. And let's compare this to what we did over here. You'd realize that the answers are the same. So which do you prefer? It's up to you to decide. It's either you simplify using grouping of like terms, or you add and subtract using the vertical column method. Let's take some few more examples. Our second question we have here, we have to subtract. We have to what? Subtract. So we'll use the first method, and then for this subtraction as well, we'll use the second method. So you'd compare the two and then take that of your choice. We have 5x squared, then plus 3x minus 1, then minus 2x squared minus 4x plus 6. So the first thing you need to do is to make sure you open your brackets. By so doing, I mean this here has 1 as its coefficient that is in front of the bracket. So everything remains the same. We have 5x squared plus 3x and then minus 1. Then we come here. The negative affects each and every term. So first of all, negative 1 times 2 gives us a negative 2x squared. Negative 1 times negative 4 gives us a positive 4x. The negative times positive, we have a negative 6. So since we've been able to remove our bracket, we now group the like terms. Grouping of like terms, we simply mean this is 5x squared. So x squared moves with x squared. Then for the x's, this x also moves with what? This x. Then for the constants, we also have the negative 1 going with the negative 6. So with that, we have our 5x squared moving with the negative 2x squared. Then we come to that of x. So positive 3x also moving with the positive 4x. And for the last one, we have our negative 1 also moving with our negative 6. Then we simply evaluate. So 5x squared minus our 2x squared, we have 5 minus 2, which gives us a 3. So we simply write our 3 and then our x squared. Then we come to the 4 and then 3. So 4 plus 3 gives us a 7. So we have our 7x. A negative 1 minus 6 also gives us a negative 7. So this becomes our final answer. Very simple, right? Okay. But then if you wanted to use the vertical or the column method, then this is how you are going to arrange it. For this, we have terms in x squared, terms in x, and then terms in what? The constant. So there is no need adding a placeholder for any of the terms. Hence, we have our 5x squared plus 3x minus 1. Then look at what I'm going to do. I'll bring my minus here. That is this negative. Then into a bracket 2x squared minus 4x and then plus 6. So as you can see, I have taken my time to arrange them. You see, I've arranged them nicely. Now let's do our evaluation. Let's start from the constant term. So we have negative 1 minus positive 6. Negative 1 minus positive 6. That simply gives us a negative 7. Then we have our 3 minus negative 4. So 3 minus negative 4, this then becomes a 3 plus 4, which is a 7. You see, so 3 minus negative 4 gives us a positive 7. Positive 7 what? X, because we are working under the x. Then we come to our x squared. 5 minus 2. 5 minus 2 gives us a 3. So we have 3. 3 what? X squared. And that becomes our final answer as well. And as you can see, it is the same as what we have over here. The same answers, but different method. So now that we understand the basics of all these, let's take it to another level by solving our third question. So let's look at our third question. Our third question this time around has 3 of the polynomials. The first one being 2x cubed minus 4x squared plus 3x minus 1. Then for the second one, we have x cubed plus 2x squared minus 5x plus 4. Then this also follows with 3x cubed minus x squared plus 2x minus 3. This time around, let's use this first method, that is the vertical column method first. Then we continue with the other one so that you can do your necessary comparison. So for the first one, we have 2x cubed, then minus the 4x squared plus 3x minus 1. The coefficient we have here is just 1, so there's no need putting it in a bracket. Then we come to the next one. So it says plus x cubed. You write that under their corresponding terms. So x cubed, then plus 2x squared minus the 5x, and then plus 4. Then I'll come to this term. This one is negative. You put your negative, then into bracket your 3x cubed plus, does it have a term in x squared? So it's minus, so minus x squared and then plus 2x and then minus 3. So this is what we have. Now let's evaluate. So we have negative 1 plus 4. Negative 1 plus 4 gives us a 3. So 3, that is from these two, 3 minus negative 3. 3 minus negative 3 gives you a 6. So in this column we have over here, this particular column, it is giving us the answer 6. Do you see? So we have 6 and it is a positive 6. Then let's come to this column. 3 plus negative 5. 3 plus negative 5. That gives us a negative 2. We have a negative 2 minus what? The positive 2. Negative 2 minus positive 2. That becomes negative 2 minus positive 2, which is a negative 2 minus 2. That gives us a negative 4. Easy. So what we have for this second term is going to be a negative 4x. Then we come to this section. So negative 4 plus 2. That gives us a negative 2. Negative 2 minus negative 1. That is negative 4 plus 2 minus negative 1. Negative 4 plus 2 minus negative 1. We have negative 4 plus 2 giving us a negative 2. Then this gives us plus 1. When simplified, we have a negative. So negative 1. Hence, for the x squared, we have negative 1x squared, which is the same as negative x squared. Then we come to that of degree 3. 2 plus 1 minus 3. 2 plus 1 gives us a 3. Minus 3 gives us a 0. So we have a 0x cubed. And that is all for this question. So our answer is simply what? Negative x squared minus 4x plus 6. You see how simple this is if we use the column method. Now, if you decided to do it gradual so that you can group like terms and then proceed, let's look at how that is also going to be. So to solve, let's first write our question. That is 2x cubed, then minus 4x squared plus 3x minus 1 in our bracket. Then in the next bracket, we have plus into bracket x cubed plus 2x squared minus 5x plus 4. And for the last one, we have negative into bracket 3x cubed minus x squared plus 2x minus 3. So with this, let's open our bracket. For those with just positive in front of them, they will just be the same as whatever we have in the bracket. Hence, this remains as it is. That is, these two over here, they are going to remain as they are. But the only thing is I'm just going to clean the brackets so that we have this. Then for the last term, it has a negative in front of it. So negative times 3x squared, we have negative 3x cubed. Then negative times negative x squared, we have a positive x squared. The negative times 2x, we have a negative 2x. And then the negative times negative 3 gives us a positive 3. So with that, we can now group like terms. For those containing x cubed, we have this x cubed, 1x cubed, and then negative 3x cubed. So for the cubes, we have 2 plus 1 minus 3. 2 plus 1 minus 3. That ends up giving us a 0x cubed. Then for the squares, we have negative 4 plus 2. That gives us a negative 2. Then negative 2 plus 1. That gives us what? A negative, so negative x squared. And then we come to the x's. A 3 minus 5 gives us a negative 2. Negative 2 minus 2 gives us a negative 4. We have a negative 4x. And then we have negative 1 plus 4 plus 3, which also gives us a positive 6. So if you want to combine all together, our answer is simply a negative x squared minus 4x then plus 6, just as we had over here. So any of the method works. The most important thing is you take your time and then work with the signs so that you don't mix them up. Let's look at one last question under this. And this one is going to be thought-provoking, so please pay attention. So this is our last question, and you can pause and then try it on your own. Then you come and then look at the suggested solution. It says you have to find A, B, and C such that 2x cubed plus ax squared minus 3x plus 5, then plus x cubed minus 4x squared plus 4 plus bx minus 2. When you add this, you would get 3x cubed plus 2x squared, then plus cx plus 3. How do we go about this? This one, you would need to form your own equations in terms of a, b, and c, and then you solve. But first of all, we know on the left hand side, we have 2x cubed then plus ax squared minus 3x plus 5. And we are adding it to this particular one, which is x cubed minus 4x squared plus bx minus 2. If you have to add this together, since now you understand how to add, I'll just go straight forward. 2x cubed plus x cubed gives us a 3x cubed. Then for ax squared minus 4x squared, that is going to give us, working on only the coefficient, we have a minus 4, you see, then all squared, because we don't know the exact value for a, hence whatever it could be, we'll just write a minus 4. Then we come to that of the x's, so negative 3x plus bx, we are going to get a negative 3 plus b with our x. And then for the constant terms, we then have what? 5 minus 2, which gives us a 3. If we are to add what we have on the left hand side, this is what it gives us. Meanwhile, we are saying that this here, which is our 3x cubed plus a minus 4x squared, then plus negative 3 plus bx, and then plus 3. We are saying it is equal to this we have here, which is 3x cubed plus 2x squared plus cx, and then plus 3. So if they are equal as we say, then it simply means the corresponding terms have the same coefficient. As you can see, we have 3x cubed here, and it is the same as 3x cubed over here. You see, the corresponding terms coefficients are the same. And it would also mean that what we have for the x squared, the coefficient would also have to be the same. What we have for x, the coefficient would also have to be the same. And as you can see, the constant, which is 3 over here, is the same as the 3 over here. Hence, let's write an equation to actually solve for a. So we say solving for a, we would have to equate the terms. That is to say, a minus 4 then x squared is equal to the term that also has an x squared here, which is 2x squared. And since they are all x squared, we just equate the coefficients. So a minus 4 is equal to 2. Making our a the subject, you see our a is equal to 2, then plus 4, which is 6. That is, a has been solved. How then do we solve for b? So for b, we use the same procedure. Look at the term that contains the b over here. So we have negative 3 plus b. It has a coefficient of x, you see. So negative 3 plus bx should be equal to what we have over here, which is cx. We then have to equate the coefficients. It simply implies our negative 3b is equal to negative 3 plus b is then equal to the c we have here. So looking at it, there are no other equations we could substitute to solve for b and then c independently. Hence, if we want to actually make b the subject, b is c plus 3. And then c on the other hand is what? B minus 3. They can be any value. Hence, if b is 1, then c is simply 4. Do you get it? So they can be any value at all and then they would work. So we can conclude by saying, therefore, A is 6 and c is equal to b minus 3, where b can be any value. That is just it. So that brings us to the end of this lesson on addition and subtraction of polynomial functions. I do hope you've learned a lot. Looking ahead, in our next session, we'll look at multiplication of polynomials. And in multiplication, we'll learn the FOIL method, that is for multiplying two binomials. We also look at some special products, then how to multiply any polynomial by distributing each term. It is important we went through this addition and subtraction because it is essential for simplifying multiplication results. You would see why when we enter into our next lesson. As usual, I'll leave you with some exercises so you try on your own to enhance your understanding. So here you have these 5 questions just to test your understanding on what we have done so far. This is Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel, you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson. Bye for now, and do stay safe.